Okay, we're going to go through the differentiation rules, and I'll actually show you how you can check your answers on the calculator. When you find the derivative, the whole process is called differentiation. Okay, and you're going to figure derivatives and do differentiation. You're going to do that in Chapter 3. Chapter 4, you're going to do applications of derivatives. And then Chapter 5, we're going to do integration. Integration is the inverse of differentiation. So every time you're finding the derivative, you're doing differentiation. Okay? And that's basically what they explain. The differentiation is the process of calculating the derivative. Okay. And when we work a problem, you will put your original, if you're to check it, you will put your original function or equation in y sub 1. In y sub 2, you'll let the calculator do the numerical derivative of y sub 1 comma x comma x. Okay? The calculator's figuring the derivative. Then you'll take your derivative that you figured algebraically. Okay? So this is the original function or equation. Then this is your calculated derivative that you've done by hand. And your derivative and the numerical derivative that the calculator figured should graph the same thing. Okay, so you turn these two on, turn the original one off, and they ought to be graphing the same thing. Okay? Okay, so that's what you're going to do for a check. Okay, now there are some rules. We're going to go through all the rules for differentiation in this section. The rule 1 is the derivative of a constant. And for a lot of these, you already know the answer. The derivative of a constant. A constant is like a number. Okay, like 5, -3. They are constants. If I said I want you to graph a constant like y equals 5. Okay, if I said graph y equals 5, what type of a line is that going to graph? Horizontal. Okay, now tell me, what's the slope of any horizontal line? 0. You already know the derivative of a constant. Okay, so if c is a constant, then now there are different ways to write derivatives. Okay, and the symbol, I'm going to use a different notation here. I've been using, in the notes so far, I've been using f prime of x for the derivative. You can also use y prime. You can use the derivative of y with respect to x. There are different ways, and I usually probably do f prime, but one year I did not teach this at all or this at all, and then I sent students off to college and they'd never seen that before. Okay, so I'm going to use a little bit of both. So as we go through, so when they say, then, now here's how you read this, the derivative of the constant c with respect to x. That just means in the formula you're using an x variable. Okay? The derivative of c with respect to x, and we already said the derivative of a constant is 0. If I gave you an equation and the variable in there was a t, then it would say the derivative of c with respect to t. And they have a dt on the bottom. It's just telling you which variable you're using. So let me show you this in different notation. If I said the derivative of 5 with respect to x is 0, if I gave you the equation f of x equals 5, that's like y equals 5, then the derivative f prime of x, f prime of 5 is 0. I could put the 5 in there for, okay? And then another way to write it, if I said y equals 5, then the derivative y prime is 0. It doesn't matter which notation you use, the answer is still going to be derivative of a horizontal line is 0. Okay? Okay, rule 2. This is called the power rule. Okay, and it says if n is a positive integer, if n is a positive integer, then, okay, and here's how you read it. The derivative of x to the n power with respect to x equals, okay, n times x to the n minus 1 power. Okay, n times x to the n minus 1 power. So if I said find the derivative of x to the 6th with respect to x. Now, what we did the other day, we did the derivative by the long method. When I said take the limit of f of x plus h minus f of x all over, this is going to shortcut that by a bunch. Okay? Take that exponent, you basically take the 6 times this number in front, which would just be 6x, depress the exponent by 1. Okay? And that's a lot quicker than what we did the other day. Okay? That's using the one notation. If I said f of x is x to the 6th, then f prime is 6x, depress that exponent by 1. 6x to the 5th. If I use the y, it'd say y equals x to the 6th, then y prime, the first derivative, is 6x to the 5th. Okay? Okay? Third rule, rule 3. Rule 3 is the constant multiple rule. The constant multiple rule. And it says if u is a differentiable function of x. Now you have to stop right there and say, what does that mean? If u is a differentiable function of x, that means you can find the derivative of it. Okay, that means what? There are no sharp corners. Okay, there are no infinite where you're going to have the discontinuities. There are no vertical tangents. The function has to be differentiable. That means you have to be able to find the derivative of it. Okay, if u is a differentiable function of x and c is a constant, then, okay, and here's the rule. The derivative of c times u with respect to x equals c, okay, then times, now it's times the derivative of u with respect to x, derivative of that function with respect to x. Okay? Now, here's what it looks like in the three forms. If I said the derivative of 7x to the 5th, I'm using 7 as my constant. Okay? I can say leave the 7 out front, that's my c. Leave the 7 out front. Times, this is the derivative of u. This is my u. What's the derivative of x to the 5th? 5. x to the 4th. Now multiply the numbers in front. 35x to the 4th would be my final answer. Okay. If I did this on the f of x, I'm going to write it 7x to the 5th, f prime of x. Okay, now here's the easiest way to do this. Just take this exponent times the number in front and then depress the exponent by 1. So 35x to the 4th. And it would be basically the same. I would change that to a y and a y prime, and it basically look the same. Okay, that's rule 3. Okay. Now the next rule they're going to put terms and add them or subtraction. Okay, so on rule 4, the sum and difference rule. And it's still basically they are differentiable functions of x. Okay? The sum rule would say this: the derivative of u plus v with respect to x equals, take the derivative of the first term, derivative of u with respect to x, plus take the derivative of the second one, derivative of v with respect to x. Okay? So let's look at an example. Say I have the derivative of x to the 4th plus 12x, and we're using an x, so it's with respect to x. Now, the way you read this, this just says find the derivative of u. This would be like my u. What's the shortcut for finding that derivative? 4x to the 3rd. You take the number, take 4 times the number in front, would be 4, depress the exponent by 1. Plus. Now this is my v. What's the derivative of that? Just 12x to the 0, but what's x to the 0? 1. Okay, and that's it. Okay, that's the sum. So basically you can take the sum and difference rule and find the derivative of each part separately. I usually don't write it that way. When I write it, I'm going to write it either with a y or an f of x. I'm going to write it f of x equals x to the 4th plus 12x. F prime, take that exponent times the number in front, depress the exponent by 1. Take this exponent times the number in front and depress the exponent by 1. And that's it. This is a much more concise way of writing it. But at least we will work with those derivatives with that notation. Okay, so you kind of got to get used to it. The only difference on the difference rule is you'd change it to minus signs in between. Okay? Any questions on that one? Okay, rule 5. I will tell you on the next 2 rules, and there's a couple more after that. When I first started teaching Calc, we went through these rules pretty quick, and then when we got to chapter 5 and we had to do everything backwards, I was going, oh my gosh, that was a teaching error on my part. I did not emphasize the product rule, quotient rule, chain rule. I didn't emphasize it enough. You got to know it forwards. It's like you got to be able to multiply to be able to divide. Okay, so I will teach you these over and over and over again. I will have these ingrained in your brains by the time you get done. Okay. Okay, so rule 5, the product rule. Okay, and it just says the product of 2 differentiable functions, and that just means we can find the derivative of them. The product of 2 differentiable functions, u and v, is differentiable. The product is differentiable. And Here's the rule. The derivative of u times v with respect to x. And for a while, try to do it in the same order I'm doing it. And there's a method to my madness for chapter 5. Start with u. You leave the first quantity. That u represents a quantity. You leave that first quantity the same. Okay, times the derivative of the second quantity. So the derivative of v with respect to x. And product rule you add in between. Then leave the second quantity the same, v, times the derivative of the first, derivative of u with respect to v. And that is the product rule. I could turn those around because of the commutative property of addition, right? But for a while, try to keep it in that order. The first one stays the same, times the derivative of the second, plus leave the second one the same, times the derivative of the first, okay? Now, I'm going to do this with just the y notation. Let's say I give you y equals x squared plus 1 and y times x cubed plus 3. The reason you know it's a product rule, yeah. Oh, that's my fault. Thanks. No, that's my fault. I think I said it. I just read it. I read it wrong. Yeah, good. Thanks. Yeah, everybody correct that to. It's with respect to x because I'm still using an x variable. Okay. Okay. This, mark this on your papers. This, that's my u, that quantity. Okay. And this is my v. Okay. So y prime says leave the first quantity the same. So it's going to stay x squared plus 1. This says times the derivative of v. What's the shortcut for taking the derivative of this? 3x squared. What's the derivative of a constant? 0, so that drops out. Now we're at the plus sign. Now it says leave the v the same. So leave the second quantity the same, x cubed plus 3, times the derivative of u. So now you got to go back to this. What's the derivative of this? 2x. And the derivative of 1 is just 0. Now, the author may leave it like that, or the author may say, hey, let's multiply this out and combine like terms. You'll have to look in the back of the book. Okay? If I multiplied that out, I would end up with, in combine like terms, I end up with 5x to the 4th plus 3x squared plus 6x. Okay? If I was going to check this, okay, the check would be put the original in. Don't multiply it out. Put the original in. In y sub 2, you would do the numerical derivative of y sub 1 comma x comma x. Then I would put my answer. I would put my answer in y sub 3, and I would turn these two on, and they better graph the same thing. If they're not graphing the same thing, that's the check that you've made an error in calculation. Because the calculator's derivative and your derivative ought to be the same. Are we about done? Rule 6. I'm going to give you the quotient rule without all the writing. Quotient rule, the derivative of u divided by v with respect to x. Quotient rule, you have to start with the numerator, or with the denominator, sorry, with the denominator. Start with v, then times the derivative of u with respect to x, minus, leave the u the same, times the derivative of v with respect to x, and it's all over the denominator squared, v squared. I still got a couple minutes, right? Why do you have to start and be in a certain order with that one? Yeah, because of subtraction. The order makes a difference. So rule 6, make a star out at the side. You have to start with the denominator. times the derivative of the numerator minus, leave the numerator the same, times the derivative of the denominator, and it's all over the denominator squared. So, example, if I said y equals 3x squared minus 5x, that's my u, and it's all over 4x cubed plus 2x to the fourth. That would be my v. Okay, so now if I do y prime, I start with the denominator. Okay, so it's got to be 4x to the third plus 2x to the fourth. Times the derivative of the numerator. What would that be? What's the derivative of this? Shortcut. 6x minus, because you take 1, so 5, right? Okay, minus. Leave the u the same, so you leave the 3x squared minus 5x the same, times the derivative of the denominator. So you look at the denominator. What's the derivative of that? 12x squared plus 8x cubed. And it's all over. Here's the most common mistake, is people forget, it's all over that denominator. And most of the time you don't square that out, you just write it like denominator squared. Okay? Okay? And then they might simplify the numerator. And if you do, this minus sign is going to change all those signs. You got to multiply that out, change all the signs. Okay? Okay. We've talked about this a little bit already. The symbols for the derivative might be f prime of x, might be y prime, might be derivative of y with respect to x. That symbol means first derivative. This is another way, derivative of y with respect to x. All four of those are first derivative. It's a way to sell textbooks. Okay? Second derivative, f double prime, y double prime. Okay, now this one's a little bit different. Second derivative of y with respect to x. You put in the exponents in there. Okay, and this one, second derivative of y with respect to x. Okay. So if you see this notation, okay, they're asking for the second derivative. So you take the derivative of the derivative. Okay. Okay, now go back to the very first thing I had you put on the board. The very first assignment. Go back to that assignment we did on Monday. Look back at that a minute. Didn't I give you 5 through 15 or something? Yep. Okay. Go to, like did we do number 7? Yeah. Okay, look at number 7. Y equals 2x squared minus 5. Now do the derivative. What's the derivative of that? 4x. Isn't that what you got by doing it the long way? Now you're going to be able to know what the derivative should be. This is the shortcut. Like on number 9. Number 9 was y equals 2x squared minus 13x plus 5. What's the derivative? What's y prime? 4x minus 13. Boy, isn't that much easier? Okay? Okay? You still have to know how to do the long way. Am I going to ask you one on the test? You betcha. Okay, but now you'll know what you should get for an answer. Okay? Now you can use the rules. Okay? You have to look at that and say, is it just a polynomial where I can just use the shortcut? Is it a product where I have to use the product rule? Is it a quotient where I have to use the quotient rule? Okay? Okay.